Hi everyone, in the previous session we just discussed about IP multicasting routing in IPv6, and now in today's session we are going to discuss about securing the switched networks. And getting into the agenda of the today's session, we just get introduced about why switching and what is a switched network and all about its features, followed by the taxonomy of the switched networks and also about the virtual switched networks and about the packet switching network, followed by the virtual circuit switched networks and the limitations of the secured switched networks. And now getting introduced about the switched networks and why do we need switching and what is all about the switched network. Getting introduced to switching, this is the concept or consists of a series of interconnected nodes called as switches, and that is termed as a switch network, and wherein a switch is a network device that is capable of transferring the data to only a particular host wherein the address is getting attached to it. It also checks the destination address to route the data packets with the proper address, and also it comes out with the following features wherein it gets operated at layer 2, that is the data link layer, and it is also capable of transferring the data only to the destination nodes with different configurations, and it transfers the data with a speed up to 100 to 1000 megabits per second as well as 10 to 100 Gbps per second. It avoids the packet collision because it is getting attached to port data connections, and also it operates in a full duplex mode. And now we'll discuss about the taxonomy of the switch network. The taxonomy of the switch networks comes into three categories. The first one is the circuit switch networks, followed by the packet switch networks. The packet switch network is further divided into two categories. The one is the Datagram Network, the other one is the virtual circuit networks, and again the third category of this switch network is the message switch networks. And now we discuss about the circuit switch network. Circuit switch network consists of n number of switches that are connected via the physical links. A connection between two stations is a dedicated path that is made up of one or more links on it. However, each connection is established using a dedicated channel on a particular link, and each link can use n number of channels that are connected either by using FDM or by using the TDM, wherein at a circuit switched network a connection can be established or reserved using the setup phases into it. And now with a picture that clearly depicts about, there are 4 switches and 4 links that are connected to it, and each link uses n number of channels by using the FDM or by using the TDM. The circuit switching network is divided into 3 important phases. The first one is the connection setup phase, followed by the data transfer phase, and the last one is the connection teardown phase. And now we discuss about the first phase is called as the connection setup phase. Before the two parties or multiple parties wish to communicate in a conference call, they get communicated via a dedicated circuit that is made up of multiple number of channels and the links that needs to get established. The end-to-end systems are connected by using the lines to the switches that needs to get established. In a circuit switching network, a link that is getting reserved or the resources that needs to get reserved during the setup phase, and the entire resources remain dedicated during the entire data transfer phase, wherein until a teardown phase is getting encountered. In circuit switching, the resources needs to get reserved only at the setup phase, and the resources remain dedicated for the entire data transfer until a teardown phase is getting encountered. The next phase we call to be as the data transfer phase. If both the parties are getting involved in a data transfer, only if the connection is getting established in a well-defined manner. The last phase is called to be as the connection teardown phase. Here, if any one of the party involved in the communication wish to get disconnected, a signal is being sent to all the switches that is getting connected to release all the resources. Now we discuss about the packet switching networks. In the packet switching networks, the messages are divided into packets of fixed and variable size. The size of the packet depends on the network as well as on the governing protocol. The resource allocation is not done in the packet switching network for every packet that is being transferred. The allocation of the resources is done only on demand. This also reveals that there is no bandwidth reservation for every packet, as well as there is no scheduled timing for processing every packet that is involved in transmission. In a packet switch network, the sources are getting allocated or the resources are getting allocated based on the first come first serve basis. When a switch is set to receive a data packet, no matter what the source or the destination node be of, the packet must wait until all the other packets are getting processed. And broadly classifying the whole of the packet switching networks into two categories. The first one is called to be as the Datagram Network, and the second one is called to be as the Virtual Circuit Networks. A Datagram network wherein each packet is treated independently of all the other nodes or all the other packets in the network, and every packet is referred to as a datagram. And now in the picture it clearly depicts that when a node A wants to get communicated to node X, wherein all the 4 packets belongs to the same messages as 1, 2, 3 and 4, wherein they travel a different path in reaching the destination node. The reason behind this is that the link is getting involved in carrying all the packets from source to the destination node. Wherever the link does not carry the necessary bandwidth to transmit the data packets together in reaching the destination or the station X. And this eventually causes the loss of the data packets, or most of the packets are getting dropped before reaching from station A to station X, that is from source to the destination nodes. And in most of the protocols, the upper layer of the protocol must be involved in reordering this set of data packets as the datagrams before they are getting reached to the destination nodes. The Datagram network is otherwise called to be as the connectionless network. It is named because that the switches does not carry the connection state every time it is getting used. And in this datagram approach, there is no setup or tear down phases are getting involved in it. This means that every packet that is involved by the switch, it treats the same, either it is a source or a destination packets that is getting reached to the nodes. And without a tearing or a setup causes or the phases, how a data packet is getting transmitted from source to a destination node. The reason behind that is every switch uses a particular routing table that carries information about the destination addresses. So this routing table is set to work in a dynamic order that updates periodically all the information or the transmission of the packets in reaching to the destination nodes. And this can be unique in the scope of the network or an internationally, where this means that the network is a part of an international network also. This also uses an VCI, which is called as a virtual circuit identifier, that is used in the global addressing of either a source or a destination node that is involved in transmitting the packets. And now let's discuss about the virtual circuit type of network. And this is a cross between the circuit switched network and the datagram network. In the virtual switched networks is normally implemented in the data link layer, wherein the virtual circuit networks are implemented in the physical layer. In the virtual switched networks, all the nodes or all the packets belonging to the same source and the destination nodes travel in the different path, whereas they reach the same destination node in different delays. And this is caused just because the resource allocation is done on demand. There are two types of addresses involved in the virtual circuit network. The one is the global address, the other one is the local address. And now let's discuss about the limitations of this secured switched networks. In getting connected to it, the network issues are involved in securing the networks. The network connectivity issues are very difficult to get followed in case of the switched networks, and whereas it is also more expensive when compared to that of the network bridges, and the broadcast traffic is also very difficult to get followed in case of network switches, and there should be proper case of designing, and also there should be proper configuration to be followed in case of handling multicast packets in switched networks. At the end of this topic, we have come to the end of the lecture series. So far in the lecture series, we discussed about network fundamentals, the routing information protocol, internet protocol IPv4, and also about the IGRP and EIRGP routing protocols, the OSPF routing protocol, the BGP routing protocol, and also we discussed about IP multicasting with IPv6, and also about the securing the switched networks. Hope you all understand about the fundamentals of network routing protocols, and in future we are going to discuss more interesting topics on computer science. Thank you.